Greetings, students. This is the second set of notes in the minerals unit. It is called Properties of Minerals. Sinc, S-I-N-C-C, that's from the first set of notes. That's how you know you have a mineral rather than a rock. But how do you identify which mineral you're looking at? In order to determine which mineral we are looking at, we must study the properties. The major properties of minerals are color, luster, streak, hardness, cleavage, fracture, and density. Color. The same mineral can be found in a variety of colors. The reason for this is minerals can form in a variety of locations. Impurities can mix in with the mineral when it forms and alter the color. Quartz, for example, can come in a variety of colors. Therefore, color is not a great identifier of a mineral by itself. These are all quartz, so you couldn't pick up one of these pink samples and say, oh, this is definitely quartz because it's pink. You couldn't pick up one of the purple samples and say this is definitely quartz because it's purple. You don't know. Based on the color, you're going to have to perform some other tests to be sure. One of those tests is called streak. Streak is the color of the powdered form of a mineral. Streak is determined by rubbing the mineral against an unglazed porcelain streak plate. Streak is not the same as color, but sometimes it's pretty much the same. Here's a bunch of different minerals and their streaks. You can see some of them have a matching color to the streak to what color the mineral is, and some of them do not. Luster describes the way light reflects off the surface of a mineral, or basically how shiny it is. Some descriptions include dull, greasy, metallic, fibrous, non-metallic, pearly, and glassy. The main thing you need to focus on is whether it's metallic or non-metallic. That's going to be the biggest clue. Once you realize it's non-metallic, you can decide if it's dull or pearly or glassy or whatever else. If it's metallic, it looks like a metal, like the one in the bottom right here. Here's a bunch of other lusters like dull, vitreous, silky, earthy, greasy, resinous, etc. Cleavage. We talked about this a little bit in the first set of notes. When a mineral breaks, it can exhibit cleavage or fracture. Cleavage refers to a mineral that breaks the same way each time it breaks. These breaks occur along flat surfaces. All samples of a mineral must break in the same way for it to have cleavage. Mica has a flat crystal structure. It breaks apart easily due to weaker bonds between the flat layers. And that would be a flat cleavage pattern on the left and a cubic cleavage pattern on the right. When a mineral does not exhibit cleavage, it may have fracture. Fracture is an uneven or irregular break. Both cleavage and fracture are typically determined by breaking a mineral. This mineral has fracture. For cleavage, look for flat surfaces. If there is no flat surfaces, you could probably just say it's fracture, although you can't always tell just from looking at it. Hardness. Hardness is determined by scratching a mineral. Hardness is a measure of the strength of the bonds that hold the mineral together. You use Mohs scale of hardness when determining the hardness of a mineral. Mohs scale goes from 1 to 10, with 10 being the hardest. Any mineral can scratch another mineral that is softer. So here's Mohs scale of hardness. Diamonds are the hardest mineral, and thus diamonds can scratch all these other minerals below them. Talc at the bottom is the softest mineral, and it can be scratched by all these other minerals above it. So if you have a mineral and you don't know what mineral it is, you could try scratching it with your fingernail. If you can scratch it with your fingernail, the hardness is below 2.5. If you can scratch it with a copper penny, the hardness is below 3.5. If you can scratch it with a knife or glass, the hardness is below 5.5. If you can scratch it with a steel nail, hardness is below 6.5. If none of that stuff can scratch it, then you know the hardness is above 6.5, and so on and so forth. Density or specific gravity. Density is mass divided by volume. Every mineral has a unique density that can't be measured. When you're talking minerals, sometimes density is referred to as specific gravity. Specific gravity means density compared to water. And here's a list of minerals with their hardness and their density. And some minerals have similar densities, but for the most part, they have a unique density. So density is one of the things you can measure to try to help you determine which mineral you have. Although if you look at topaz and diamond, they have exactly the same density. So if you had a mineral and you weren't sure what it was and you got 3.51 as the density, you might need to test the hardness or something else in order to determine what you have. To find the mass, you use a triple beam balance or a digital scale. To find volume, water displacement works well for irregular shapes. So that's when you have an initial level and you drop something in, and then however much it raises up is the volume of the object that you dropped in there. If the mineral is a regular shape, like a cube or a rectangle or something, you can do length times width times height. And that also works for volume. So those are the major properties. We're going to talk just a little bit about some special properties that only apply to very specific minerals. Double refraction occurs when a ray of light enters a mineral and is split into two. Common in carbonate minerals. Calcite is a good example. Magnetism, magnetite, notice the name, is strongly magnetic. Taste. Halite is the best example of this since it is rock salt and it tastes salty. Tasting a mineral should not be a priority for anyone trying to identify one. Some minerals can be poisonous. The carbonate minerals tend to react well with hydrochloric acid. When HCl is placed on them, bubbles and fizzing occurs. That's another special property. Fluorescence is also a special property. Fluorescent minerals are minerals that give off visible light when placed under ultraviolet light. Examples include fluorite, talc, and quartz. And so, if you were going to go out and identify minerals in the field, what tools could you bring with you to make your job easier? Well, you could bring a UV light to test the fluorescence. You could bring some hydrochloric acid. You could bring your tongue. You could bring a magnet. You could bring a laser pointer. You could bring a graduated cylinder and some water and a triple beam balance. You could bring all this stuff on Mohs hardness scale, like a copper penny and a knife and a glass plate, steel nail, masonry drill bit. You could bring a hammer to break it apart and see if it has cleavage or fracture. And all this stuff is only going to be helpful to you if you have a key that tells you what the different densities, hardnesses, and lusters of various minerals are. You're going to want a streak plate, that's for sure. And that'd probably be enough stuff. Maybe a magnifying glass or a microscope as well. And that is all for this set of notes. Have a nice day.